Accuracy and precision. So in chemistry, the meanings of accuracy and precision are quite different. So accuracy is a measure of how close a measurement comes to the actual or true value of whatever is measured. Precision is a measure of how close a series of measurements are to one another, irrespective of the actual value. So, great example here is a dartboard, right? We know playing darts, our accepted value, our target value is the bullseye, okay? So this thrower, right, had 3 throws or 3 trials, okay? So we could see all 3 of his throws were at the darts, right at the bullseye, okay? So he's very accurate, so good accuracy, right? And another thing about precision before we talk about what this dart player, how he threw there, okay, right? Precision, how close the values are to one another. Right? So how close they are to one another. And in this picture, it definitely looks like all 3 are at the bullseye. All the data points or darts are in the same location, right? So there's good precision there. Now, if we look at the middle dart board, okay, remember we want to get to the bullseye, but it's nowhere near the bullseye, so it's poor accuracy, but it's very precise, right? They're all in the same location, okay? Now, the last dart looks like me throwing darts, okay? So it's nowhere near the bullseye, okay? So poor accuracy, and all the data points or darts are nowhere near each other, right? So there's poor precision there. Okay, so determining error. There is a difference between the accepted value, which is the correct value for the measurement based on reliable references, and the experimental value, the value measured in lab. The difference between the experimental value and the accepted value is the error. So our main formula is the percent error. So the percentage error of a measurement is the absolute value of the error divided by the accepted value multiplied by 100%. So experimental minus accepted all over accepted times 100%, right? Remember, our unit is a percentage, so our unit will be a percent. So for an example, it says the boiling point of pure water is measured at, or to be, 99.1 degrees Celsius. Calculate the percent error, right? So percent error, experimental minus accepted, all over accepted, times 100%. Okay, so now our experimental, what we measured, 99.1. minus the true value or the accepted value, okay? And this is a reference value, so pure water boils at 100 degrees Celsius, so it's 100. All over 100 times 100%. So, plug this in my calculator, 99.1 minus 100. Remember, it's absolute value, so it's going to be, and I'm going to put this up here, it'll be 0.9 all over 100 times 100%. So 0.9 divided by 100 times 100%, and we get 0.9% error. And one last question here. So are precise measurements always accurate? Okay, and by looking at the dartboard, I think we all could say that this is not the case. So no, right? Measurements are precise if they are easily reproducible, right, together. Not accurate if they do not reflect the accepted value. Right? Hence the middle dartboard when the bullseye is here and all 3 darts are up top of the 20s. Okay? Right, so this concludes our video on accuracy and precision.